up today. So if you plug negative 3 into this equation, if you do negative 3, can't write, 3 squared plus 5 times negative 3 plus 6 over negative 3 plus 3. On the top, you're going to have 9 minus 15 plus 6, which is going to give you 0. And on the bottom, you'll have 0. And 0 over 0 is called the indeterminate form. It tells us we can't determine anything about this. So for a problem like this, what you want to do is you want to factor it. So you'll say the limit as x approaches negative 3 of, factor the top, and it factors into x plus 2, x plus 3 over x plus 3. And once you factor this, you'll notice what happens with those x plus 3's. They cancel out. That's where you had a hole in the graph, and that's the point that we're looking at, is that hole. So now, once those are canceled, we can just plug in our negative 3. So if we plug in negative 3 now, we've got negative 3 plus 2. If you wanted to, you could put it over 1, but that's canceled out, so you don't have to. And so that's going to give you negative 1. So your limit here is negative 1. So you factor, cancel, plug in the number. Okay. This you only do if you get 0 over 0. If you get a number when you plug in the number, that's your answer. If you get a number over 0, like 5 over 0 or 10 over 0, the limit does not exist because that is undefined. But if you get 0 over 0, that tells you to keep going. There might be a limit, there might not. Okay? So that dealt with the factoring. The next part that we're going to look at, and if you're not quite getting that and you didn't get a chance to do the notes, you might want to look at those after we finish this part, because it's explained in more detail there. For number 2, we see the limit as x approaches 1 of the square root of x minus 1 over x minus 1. And if we plug in 1, which is where our limit is approaching, we're going to get 0 over 0. And 0 over 0 does not tell us anything except for you need to keep working on this problem. It does not tell us that the limit does not exist. It does not tell us that the limit does exist. It means we've got to do some more work. So, this one is probably something you have not really seen done before, the way that you solve this. You guys have factored and canceled things a lot before, maybe not in terms of limits, but factoring and canceling should be fairly familiar. So for this one, we're going to have to do something kind of strange that you probably have not done before. And we'll rewrite the problem here, x minus 1 over x minus 1. We're going to have to do something called multiplying by the conjugate. Okay? It sounds crazy, but our goal is to get the square root out of the numerator. It just usually sometimes works on a problem that looks like this. So the way that we get rid of that square root out of the numerator is we've got to make a difference of squares in the numerator. So if we have the square root of x minus 1, we want to multiply it by the square root of x plus 1. And if we multiply a fraction by the square root of x plus 1 on top, we've got to multiply that by that same number on the bottom, or else we change the whole value of the function. So we've got to multiply by square root of x plus 1 over square root of x plus 1. Now, let me show you why that works here. So what I would do here is I would start distributing. And so I would distribute, and what is the square root of x times the square root of x? It's just x, right? Because you'd have square root of x squared, which square roots and squares undo each other, so it's just x. So we've got, keep your limit notation, limit as x approaches 1 of, so we'll have x. And then we will multiply the square root of x times 1, so we'll get plus the square root of x times 1, which is just square root of x. And then we'll multiply negative 1 times the square root of x, so we'll get minus the square root of x. And then we'll multiply negative 1 times positive 1, and we'll get a minus 1. Now, just to give you a hint about these problems, you generally don't want to multiply the bottom together. It usually makes it more difficult because what you want is for something to cancel. So don't multiply the bottom together. Just leave it x minus 1 times the square root of x plus 1. Leave it factored out. And so if you'll see what happens here by using that difference of squares on the top, the positive square root and negative square root cancels out. So all we have for this is the limit as x approaches 1 of x minus 1 over x minus 1 times the square root of x plus 1. So multiplying by that conjugate in the top gets rid of your square root in the top and should make it where what you're left with will cancel. So do be careful here because this is the limit as x approaches 1 of 1 over the square root of x plus 1. That numerator canceled out, but you've got to put a 1 there to hold its place. You can't just move that square root of x plus 1 up to the numerator. And then you're just going to plug in the 1. And now, square root of 1 plus 1, we get 1 over 1 plus 1, which is 2, so we get 1/2 as our answer. Okay, questions? Okay, so if you see one with the square root in it, this is probably what you're going to do. Let's do another one with the square root. Okay, all right, so this one's a little more complicated. We've got the limit as x approaches 5 of the square root of x minus 1 minus 2 over x minus 5. But we're going to do the same thing that we just did. Well, actually, first we should plug in 5 and make sure we get 0 over 0. And if you plug in 5, you get the square root of 4 minus 2, which is going to be 0, over 5 minus 5, which is 0. So this is an indeterminate form. We've got to do something to it so that something will cancel, and then we can plug in the number. So what sometimes is difficult for students is deciding what the conjugate is, especially whenever it's a little more complicated like this. So here in that numerator, my first term is the stuff under the square root. My second term is that 2, so it's the sign between those two that needs to change. So whenever we multiply this, we'll be multiplying it, and it's good to go ahead and put parentheses around your top and bottom. You're multiplying it by the square root of x minus 1 plus 2. So you're changing that sign that's in between the two terms. You don't change the minus sign that's inside of the square root. Okay, so in this case, don't multiply the bottom together. You want it to cancel, so you want it to be factored out. But the numerator, we want to multiply it together in hopes that things will cancel and we'll get something that will cancel with the bottom. So if we distribute here, what's the square root of x minus 1 times the square root of x minus 1? It's going to be x minus 1. When you multiply a square root of something by the square root of the same thing, it just gets rid of the square root, because essentially you're just squaring it when you do that. So we're going to have the limit as x approaches 5 of, and then so we'll get x minus 1. And then you'll notice here, I'm not going to write it this time. When you multiply the outside terms, you get 2 square root of x minus 1. But when you multiply the inside terms, you get negative 2 square root of x minus 1. It's designed that way. That's why we chose to use that, so it would be a difference of squares and the middle parts would cancel out. So I'm not going to write them this time. You can if you want. But those two parts cancel out. And then you've got negative 2 times positive 2, so you've got a minus 4 that I can't write for some reason. And that's over x minus 5 times square root of x minus 1 plus 2. And then, of course, we can put the negative 1 and negative 4 together, which will give us x minus 5 over x minus 5 times the square root of x minus 1 plus 2, and then our x minus 5s can cancel. So as soon as you cancel something, it's probably going to work if you plug in the number now. So in the top you would just have a 1 because nothing's left there. In the bottom you would have the square, oops, that's way too long. You would have the square root of x, or 5 minus 1 plus 2, and that is going to give us 1 over the square root of 4 plus 2, which gives us 1 over 2 plus 2, so we get 1/4 as our answer. Okay, questions? Okay, I think we've got one more of these. So we did an easy, a medium, now let's do a hard one. All right, so for this one, you've got that square root. You're going to do the same thing. You're going to try to multiply by the conjugate. And so for this one, the conjugate is going to be the square root of x squared plus 5. Don't change anything underneath that square root. Plus 3, like that. And one of the biggest things I see kids do wrong on these is they forget to multiply the top and bottom. They only multiply the top. So make sure that you multiply the top and bottom by this here. Okay, questions? Okay, so you're going to distribute here when you multiply those two square roots together. Keep your limit notation. You're going to get x squared plus 5. And then when you multiply you'll multiply the outside terms and the inside terms, and those cancel, which is why you picked this in the first place, so they'd cancel out. And then you multiply the last two terms together, negative 3 times positive 3, and you get a negative 9 over x plus 2 times the square root of x squared plus 5 plus 3. Now, here's the problem. This is why this problem's a little harder than the others. Look what happens when I combine my 5 and my 9 here. I'm going to have the limit as x approaches negative 2 of x squared x squared minus 4 over x plus 2. What kind of crazy thing that just did. X plus 2 times the square root of x squared plus 5 plus 3. So whenever you look at this, does anything cancel? It does not. Which is disappointing because if nothing cancels, you're still going to get 0 over 0. But I know you can't read that numerator because it looks so bad, but that's x squared minus 4. Is there anything we could do to x squared minus 4 that would make something cancel? What? X plus 2 times x minus 2. We can factor that numerator. So if we do, we've got the limit as x approaches negative 2 of x plus 2 times x minus 2 over x plus 2 times the square root of x squared plus 5 plus 3. And so when we look at that, now our x plus 2's can cancel. So this is sort of, it's an advanced problem because not only do you have to do the rationalization, you also got to do that factoring and canceling like we did on the other problems. So then you're going to plug in your negative 2, so you have negative 2 minus 2 over the square root of negative 2 squared plus 5 plus 3. So that'll give you negative 4 over square root of 9 plus 3. And square root of 9 is 3. So you get negative 4 over 6, which will reduce to negative 2 over 3. Can't read that at all. No. Still pretty bad, but negative 2 over 3. Okay, questions? All right. Those are the main two types we're going to see that I am going to need you to do algebraically, but there's a possibility that you might see some piecewise functions as well. So let's look at a piecewise function. I'll give you a second to copy this one down. Piecewise function, you might be given a piecewise function and I ask you for a limit from a piecewise function. You could be given a piecewise function and it could ask about the continuity of the piecewise function. So in order for a piecewise function to be continuous, all the open circles have to be filled in by closed circles. You have to have the same values at every point where they intersect. So by looking at the limits, you could kind of see some of these as well. So we'll look at how to do a couple different things here. So for this piecewise function, they're probably going to ask you about the places where the pieces of the graph meet. We did piecewise functions back towards the beginning of the class. We graphed them some. We did all of those tax bracket problems that were piecewise functions. We're looking for those dotted lines where we took those sticky notes and we cut them where those two pieces went together. So, like, for example here, example 11 is asking you to find the limit as x approaches negative 2 from the right. Okay? So, if you think of the graph, sort of, I'm going to draw like a bad graph here. And so, the graph splits at negative 2, and then it splits again at 5. All right? And your equation here for everything below your -2 is 5, so it's just a horizontal line right there at 5. Then from -2 to 5, you've got some sort of decreasing line. I don't really remember whether these are continuous or not, so I'm just going to kind of draw something in there, but you've got the line that, here, let me see. Let me do this. We'll do that in black. Let's do this in blue. And then we'll do this one in red. Here you've got like an upside down quadratic moved up 4, so it's probably going to be like, probably going to look like this, maybe. Actually, it's probably going to be lower than that, but we've got this here. So you can sort of see what we might have there. For example 11, we're looking from -2, and so for -2, what we're going to do is if we're looking from the right, we're going to pick this side, even though it may not be defined there. So we're going to pick this equation, and we will plug in -2. So we'll pick, oh, sorry. -3 times -2 minus 1. So you'll get 6 minus 1, which is 5. So you just pick the equation that would be on that side and plug the number in. Okay. For 5, if you're looking from the right, then that quadratic is the equation that's on the right of that line. So you would plug in 5 into the bottom equation. So you would say -5 squared plus 4. So -25 plus 4. And that's going to give you -20, 21. I can't write 21. It's 21 right there. Doesn't look like it. Okay, here's the next few. I want you guys to try those on your own for a second. All right, so for 4 falls between -2 and 5, so you're just going to plug it into that equation. So -3 times 4 minus 1. So you'll have -12 minus 1, which will be -13. For 5, this is from both sides, so you already know the limit from the right is that negative 21. So from the left, you would need to plug it into the negative 3x minus 1. So if you do negative 3 times 5 minus 1, you're going to get negative 15 minus 1, which is negative 16, which does not equal negative 21. So that one is going to be does not exist. So if you get a piecewise function and it's a limit from both sides, you're going to pick, you're going to plug into both equations and they have to match to have that limit. And then for 15, for your limit as x approaches negative 2 of f of x, this is going to be the limit as x approaches negative 2 of f of x. You're looking from both sides here. We already found from the right side on number 11. So if you go up here, the left side is that top equation. It is just 5. Since both of those are 5, then your limit from both sides here is 5. Okay, here's the last kind of problem you're going to see. If you plug in 0 right now, you're going to get 0 over 0. And so your goal here is to get rid of the complex fraction. So if you get rid of the fraction inside of the fraction, then that will probably make it where you can find the answer. There's a few ways that you could do this. You could get common denominators on the top and then flip and multiply. Or the way I would probably do this is you could put that x over 1, and then dividing fractions is easy as pie. So the top is 1 over x plus 2 minus 1 over 2. And then we would flip and multiply. So we'd multiply that by 1 over x. And then we'll distribute here. And so when you distribute here, you still got your limit as x approaches 0. And you've got 1 over, and in the bottom you'd have x times x plus 2 minus 1 over 2x. As it is right now, you're still going to, well, right now you get 1 over 0 minus 1 over 0. I think we need to get common denominators here. So if we multiply this by 2 and this by x plus 2, we'll have the same denominators. You could have done the common denominator first. It's just whichever one you choose. So that will give us the limit as x approaches 0 of 2 minus x plus 2 over 2x times x plus 2. So you got 2 minus x minus 2 over 2x times x plus 2. And so here the 2's will cancel. And once those 2's cancel, you got a negative x on top and this x on bottom, so the x's can also cancel. So that will give you the limit as x approaches 0 of negative 1 over 2 times x plus 2. And now that something has canceled, you're going to plug in the number, and that'll give you negative 1 over negative 4, so you get 1/4 for your answer. Do keep in mind, on your test, I'm going to allow you to use your calculator and Desmos on the entire test. So if you get stuck on one like this, it's pretty long and easy to make a mistake on, you could always graph it and look at the graph, or you could put it in the table and look at the table close to 0 if you get stuck on those.